ሰላም ሰላም እንዴት ናችሁ? ይህ ማትማቲክስ ፎር ዩ ዩቲዩብ ቻናል ነው። ዛሬ ይዤላችሁ የቀረብኩት ስለ አርጊመንት ኤንድ ቫሊዲቲ ይሆናል። Within this video, we'll see the definition of argument and just a technique just to identify whether the given argument is valid or invalid. So let us start our discussion by defining what an argument is. Just as a definition, the argument is an argument of logical deduction is a set of initial statements called premises and followed by this one that's simply a conclusion. So that just simply an argument is a combination of that set of initial statements combined or simply yield or gives a certain conclusion that simply this one. So that combination of these two will form a deduction which is said to be an argument. Such a logical deduction or simply this argument can be represented by using this one horizontally. That is, we have P1, P2, P2, and that will have to this one or simply any number of this one that is PIs, which are considered as initial statements, and the capital letter Q or simply this one could be considered as a conclusion. So that the combination of these premises with the conclusion that simply Q form a logical deduction which is said to be an argument. Notationally, vertically, the way we can represent or simply this one by using in this form. And that means we have the premises from P1 to that of this one that's simply any number of PIs or points, and the horizontal line that's simply therefore we have this conclusion that's simply called a Q. So that such a statement or simply set of statements will form this one that is an argument. Then if we proceed to the definition of the second definition for this video, we have this one that's an argument of this form is said to be valid if the conclusion that's simply Q, that's simply the conclusion of this statement that this Q is true whenever all the premises P1, P2, P3 up to this one that's simply P and R true at the same time. Otherwise, it is invalid. That means the given argument of this form or simply this argument will become valid only when the conclusion that is Q is true whenever all the premises of this argument is true at the same time. Otherwise, that means the argument or simply this argument will not be considered as valid or simply it is invalid if we can get at least one possibility for which the conclusion that simply Q is false whenever all the premises that simply PIs are at the same time. So that if this condition is satisfied or simply if this condition exists, that means the condition where the conclusion that is Q is false whenever all the premises are at the same time, that will be a sufficient condition for the argument or simply this argument not to be valid for in general, which is this one which is invalid. Another important thing here is that in order to check the validity or simply whether the given argument is valid or invalid, we have to follow the following steps. The first step that we should follow here is that we have to identify which set of statements are the premises and which are the conclusion for the given argument. You know that, for example, in general, if we see here, all the statements are simply P1, P2, P3 up to this point, any number of PIs which depends on the type of the argument here, so that these are premises, and the conclusion is here a single statement that is Q. So that in order to check the validity of such an argument, our first step must be identifying which statements are the premises and which one is the conclusion for the given argument. Next one is after identification of the premises and the conclusion. Next thing will be if we are using a truth table just to check the validity of the given argument, we must construct a truth table showing the truth values of the premises and the conclusion. Then after preparing such a table which contains the truth values of the premises and the conclusion, that the last one will be, we must look or simply look for all the rows where the premises are all true at the same time. We call such rows are said to be critical rows. That means the critical row of the given truth table could be a row where all the premises are true at the same time. So that after simply selecting these critical rows, conclusion or simply the last one will be if the conclusion is false in a critical row, then the argument is said to be invalid, that is not valid. But in all the possibilities of the critical rows, if the conclusion is true, so that will be a condition for the given statement or simple argument to be valid. Okay. If we consider some examples of the validity of an argument, it says determine whether the following arguments are valid or invalid. First argument is this one, and that is we have about two statements or simple statements or premises, Q implies Q and Q implies R, and the conclusion is Q or Q implies R. And the second could be this one, and third one is in a statement form, that is Admas was the motive for the crime only if the victim had money in his pockets. But Admas or Helen was the motive for the crime. Therefore, Helen must have been the motive for the crime. So that we can see how we can check or simply how we can determine whether these arguments are valid or invalid. We start from the first one, that is simply this thing. We have, that means for the time being, we must use a truth table for checking whether this statement or simple argument is valid or invalid. And therefore, here we do have our first step just to check the validity of this statement could be, we must check or simply identify first which statements are the premises and which one is the conclusion for this argument. You know that we have this one in the first premise, they hit the second premise for this argument, they hit that therefore, so that this one is the conclusion for the given statement. Then after identifying or simply differentiating the premises and the conclusion of the statement, the next will be just preparing a table which contains the truth values of the premises and the conclusion of this argument. Table looks like that of this one. Now, because here we have three simple statements B with this one that simply R, so that the truth table will contain about 8 combinations, simply 8 rows. So the critical rows for this one could be, because the premises are implies Q, that is simply this one. They hit the first row, the row of the first premise for the given argument, and the second one is Q implies R, that's simply this one. And the conclusion is the last row of this table, that's simply this one. Therefore, let us select the critical rows for this one. That means critical row of this table means a table or simply a row where all the premises that is P implies Q and Q implies R are true at the same time. First one is the first row, that's simply this one. This is the critical row because both P implies Q and Q implies R are true. But if you see the second one, this is true, but this one is false, so that the second row cannot be taken as a critical row because the second premise that is implies R is false here. Next, the second critical row is this one, that's simply this row, because both the premises are true at the same time, so that this row, this one, and lastly, that's simply this one. Simply, we have about 4 critical rows. Therefore, in order to check or simply just to conclude whether this argument is valid or invalid, so that we must check whether the truth value of the conclusion that simply P equal Q implies R is true or false over this critical rows. For example, in the first critical row, they are true, the conclusion is also true. So that this is true. Therefore, second one is these two are true, so that the conclusion is also true. Third, it is also true here. The last critical row, that's simply the is, which is true here. Therefore, as we clearly observe from this table here, because the conclusion that is P or R implies R, I mean P or Q implies R is true, whenever all the premises are true at the same time, so that this will be a condition for this argument to be valid, so that it is his valid statement. It is valid. Because there is no any condition where the conclusion that simply this conclusion is false whenever the premises are true at the same time. Okay, let's proceed to the next example. Second example is this one. That means here again, like the first one we have about the first premise is this one, that's simply P or Q. Second one is P implies negation of Q. Third one is P implies Q, and the conclusion is this one, that is R. So that this argument is containing three premises and the conclusion single statement or simply simple statement, which is R. So that again, after differentiating the premises and the conclusion for this argument, if we see the table for this one, truth table for this one, the truth table will look like this one. So, as we clearly observe here, this argument is containing about three critical rows. Critical rows, that means the rows where all the premises are true at the same time. Really, the premises are the first premise is this column, that's P or Q. Second one is P implies negation of Q. And the last one is P implies R. And the conclusion is this column. We hit the conclusion, that is R. Therefore, the critical rows for this one could be, that is, the three premises are true at the same time here, so that over this row, the conclusion that is R is also true. That is this one. Second critical row is this one, that's simply the seventh row of this table. So that here, the conclusion that is R is also true. But if we see the last critical row, which is the last row of this truth table, even though all the premises or simply the three premises are true at the same time, but the conclusion that simply R here is false. So that this will be a sufficient condition for this argument not to be valid or simply invalid. Therefore, this argument is not valid or generally invalid. It is invalid because of the existence of the last row, that's simply this row, where all the premises are true, but the conclusion that is R is false here. So that due to the existence of this row, this argument is an invalid. This is not valid. Okay, the third and the last one is when statement 4, when it says Armaso was the motive for the crime only if the victim had money in his pockets. They hit the first premise, but Armaso or Helen was the motive for the crime. This one is the second one. Therefore, that is, statement just after this one will be the conclusion, that is, Helen must have been the motive for the crime. So that they hit the conclusion. And then our first thing, in order to check the validity of this statement will be, we have to change first this statement into symbolic form, an argument in the form of that of symbols. So that in order to do this, let's assume that he will be a statement or simply P can represent a statement which is Admas was the motive for the crime. From this one, we have a statement that Admas was the motive for the crime. only if the victim had many in his pockets. So that let us represent the first statement of this logical implication by P, which is said to be Armas was the motive for the crime. The next one will be over the first premise again. The victim had money in his pockets. And lastly, we have the third one, that is Helen was the motive for the crime. Then the symbolic form of this argument will be, or simply this argument will be represented or translated into this one that simply implies Q, that is the first statement, which is Admas was the motive for the crime. Only if the victim had money in his pocket, this will be this logical implication that implies Q. And second one would be, but Admas or, because of his logical destruction, Admas or Helen was the motive for the crime, so that P or R, and therefore the statement just next to this point is the conclusion, that is Helen must have been the motive for the crime, because the statement is represented by R, so that the conclusion for this the statement is R. Then the validity of this could be depends on this symbolic form of the argument, which is this one, that means simply implies the first premise, Q or R, second premise, and the conclusion is R. And from this statement, I must what the motive for the crime only if the victim had money in his pockets will be the first premise, which is implies Q. And but Admas or Helen was the motive for the crime. This is second premise, which is represented by P or R. And the conclusion would be Helen must have been the motive for the crime, that is R. Then, again, using or simply preparing a truth table for this could be because the argument is containing two premises that are P implies Q, and this one that's simply P or R, and the conclusion is this element that's simply R. Therefore, let us select first or simply differentiate the critical rows first. The rows where both the premises are true at the same time. First row that's simply at the weak really over here. It is the critical row, which are both P or R and P implies Q are true. And also the truth value of the conclusion that simply R is also here. The second critical point, or say I mean critical row, the conclusion that is R is false here. So that this could be a condition for the this argument not to be valid or simply invalid because of the existence of this one. Whatever the truth values or simply the properties of this, the other critical rows are, because in the second critical row here, both P implies Q and P or R are true at the same time, but the conclusion here is false, so that this will be a sufficient condition for this argument not to be valid or invalid. Therefore, it is not valid. It is not valid here because of this row. Okay, then after having seen the example, let us see some arguments which are accepted as valid arguments. That means just a rule of inferences. Some of below are some valid arguments which are called rule of inferences. We have about 10, which are related to that of each other. First one is modus ponens rule. That means in the case of this one, that's modus ponens rule, we have P implies Q, and the conclusion is Q, so that this, if we have, or simply if we are given such an argument, this argument is always valid because we assume that this one that simply P is true, and P implies Q is also true, which is the second premise of this one. If P is true, for P implies Q to be that and true, Q must also be true. So that Q is the conclusion, therefore, the conclusion Q is true whenever P and P implies Q is true, so that this is valid. So that this is the first rule of inference, which is said to be modus tollens rule. The second one is modus tollens rule. We have this, or simply this argument with premise negation of Q implies Q and negation of P, which is the conclusion for this argument. In order to justify for this one, for example, we assume that this one negation of Q is true. So that this one that simply Q must be false. If Q is false here, for P implies Q to be that of true, P must also be false at the same time. If P is false, so that is negation, that's negation of P be true here. Therefore, negation of P, which is the conclusion of the statement, is true whenever the two premises are true. Therefore, P is also valid. Second one is principle of syllogism, that is P implies Q, Q implies R, then the conclusion is P implies R. Here, for example, if we assume that P implies Q is true and Q implies R also, this one that's simply true, the conclusion P implies R must also be true. For example, if we assume that for this one that simply P implies Q to be that of true, let's assume that P is true here. If P is true, Q must also be true. If Q is true here, or Q implies R to be true, R must also be true. Therefore, P implies R will become true implies true, which is true again. But if we assume that Q is false, or P implies Q to be that of true, Q can be either true or that of false. But for example, that simply, if we assume that this one is that simply Q is also true here, Q is true, this one that is R is true, so that here this one is false, but this one is true, so that false implies true is true. If we assume that both P and Q are false, what will happen? This is true, this is false. R can be either true or that of false, so that because this one that simply P is false, therefore whatever the truth value of R here is, P implies or simply or false implies R is always true, therefore this is valid argument. Next one is principle of adjunction. We have P here, we have Q here, the conclusion is P and Q. So if both P and Q are true at the same time, P and Q is also true, and this is valid. Another way of writing, if we have this premise that simply statement Q is a premise and P or Q is a conclusion, if Q is true, whatever the truth value of P here is, P or Q is true, so that P or Q is true whenever the premise Q is true, therefore P is also valid, and this rule is said to be principle of adjunction. When we go to the second one, that's principle of detachment. We have P and Q. The conclusion could be either P or second component statement, which is Q. We know that for P and Q to be that of true, both P and Q must be true at the same time. So that whatever the conclusion here is, either P or Q, so that if P and Q is true, Q is also true, Q is also true, so that this is also a valid statement. And this rule is said to be principle of detachment. The sixth one is modus tollens. If we have such an argument with two premises and the conclusion that's simply Q, with premise and negation of P and P or Q. So that, for example, in order just to justify the validity of this one, if negation of P here is true, because since it is a premise, so that for P or Q, that means for if negation of P is true, P must be false. So that for P implies for P or Q to be true, the only possibility will be Q must be true, therefore Q is the conclusion, therefore in this case, this is valid argument. And this rule is said to be modus tollens. Next one is modus ponendo tollens. With this argument or simply this form of argument, that is the negation of P or Q. Now we have P here, and the conclusion is negation of Q. It has started from this one. If P is true, for P or Q, or simply for negation of P or Q to be that of true, and the interior one, that's P or Q, must be false first. But what is P? P is true. So that if P is true, what must be Q? What must be Q? Q must be false at the same time. Okay, P here is true. Is true. Whatever the truth value of this one is, no, I think this could be an error. And that means there is no, if P is true, and there is no any possibility for the negation of P or Q to be true, because uh, whatever the truth value of this one is, P or true or Q is true, the negation of true is false. So that you justify this value. Okay, let's proceed to the next one. The next one is a principle of, or simply this one, that is constructive dilemma. We have P implies Q and R implies R, and then we have P or R, and the conclusion is Q or S. So that this argument is also valid. Not just to justify, for example, for this one, for we have two premises here. Know that for P implies Q and R implies S to be that of true, both P implies Q and R implies S must be true at the same time. Therefore, let us consider this one, that simply P or R to be true. But for this to be true, we know that at least one of the component statements must be true. Let's assume that P is true. This one is true. If P is true, or P implies Q to be that of true, what must be Q? Q must be true. So that if Q is true, whatever the truth value of S here is, Q or S will become true statement, so that in this case, this is valid. But if we assume that this one, that simply R is true here, or R implies S to be that of this one, that's simply true here, if we consider R is true, S must be true. So that whatever the truth value of Q here is, because this one or simply this is true, therefore Q or true will become true, so that this is valid argument. The next one is principle of equivalence. We have P if and only if Q. We have P, the second premise, and the conclusion is Q. It's true here because it is a premise, so that for P if and only if Q to be that of true, Q must also be true, which is the conclusion of this one, therefore this is valid. The last one will be principle of conditionalization. We have P here, the conclusion is Q implies P. If P is true, because for this logical, within this logical implication, the conclusion is true here. Whatever the hypothesis or simply Q here is, Q implies true is true, so that there is also valid argument. So that these are the rule of inferences which are applicable or simply advantages for checking the validity of some arguments or simply argumentative statements. Then, depending on the rule of inferences that we have seen previously, let us see the formal proof of validity of arguments. First, let us define what formal proof of an argument is. The definition is that a formal proof of a conclusion Q, the conclusion of the argument, that means given the hypothesis that simply P1, P2, P3 up to this point that simply Pn is a sequence of steps, each of which applies some rule of inferences to the hypothesis previously proven statements or antecedents to yield a new true statement or statement. So that by following such a procedure, or simply the steps, of which applies some rule of inferences, and using that of the previously proven facts or simple statements, we can justify or check the validity of any given argument. If we see examples over this, we have this one that simply use formal proof just to check the validity of the following arguments. The given arguments as an example here will be, first one is P implies negation of Q, the first premise. P, the second one, R implies Q, and the conclusion is negation of R. Second example is negation of P or Q, R implies P, R, therefore Q. Next, P implies Q or R, negation of R, P, therefore Q. Second one is special example, which is containing quantifiers. There exists at least one x. P of x implies Q of x. First premise, for every x, P of x. Second premise, and the conclusion is for every x, P of x implies Q of x. So let us see how we can check the validity of this argument using the rule of inferences or simply formally. If we start from the first one here, we have this one. We have to use two elements, statements, and the reasons here, second element for each statement here. The first one is that because the premises here are P implies negation of Q, P, R implies Q, and the negation of R is the conclusion for this argument. We have P is true because P here is premise, so that we can consider this one as a given. Then if P is true here, for the first premise, P implies negation of Q is also true. And therefore, because this is true, so that negation of Q must also be true. Negation of Q is true. Because of what? Because here, for this logical implication, the hypothesis that simply P is true, so that if the conclusion negation of Q is false, true implies false can never be true, so that for this logical implication to be true, if negation of Q here, that is, if P is true here, negation of Q must be true, so that is why negation of Q is true. If negation of Q is true, what about Q? Q is false, just the definition of negation. Then the next one could be R implies Q is true, because R implies Q here is a premise, so that if it is a premise, we have to consider this one as a true or simply as a given. Then from this, we have R is false. Why? Because Q here is what? This one is false. So that if R is considered as true, true implies false can never be true. But or R implies Q to be true, because Q here is false, so that R must be false. If R is false, the negation of R is true. From 6, that's simply this one, that is R is true, so that its negation will be true. But the negation of R is the conclusion of this argument. So that because when we consider all the premises are true, the conclusion which is negation of R is also true. Therefore, this will be a condition for this argument to be valid. Therefore, it is a valid statement. Okay, the second example, that's B, negation of P or Q in the first premise. We have again R implies Q, second premise, and R is another premise, so that the conclusion is Q. Then formally, the proof of this one will look like the following. It has started from the simplest statement that simply premise, which is R here. R is true, since it is a premise, so we can consider this one as a given. Next one is R implies Q, R implies P is also true because the second premise or the other premise for this argument. But for this one, R is true here. R implies P must also be true. So that because the R is the hypothesis or simply the if statement for this logical application, therefore for this to be true, P must be true at the same time. So that the next one will be P is true. From property or simply the definition of implication here. The next one is negation of P is false, because here P is true, so that the negation of a true statement is false, so that negation of P is true. But from the first premise of this one, or simply this statement, negation of P or Q is true, but negation of P is false here. So what can we say about the truth value of Q here is that for this logical destruction to be true, at least one of the components must be true, but the first component, that is negation of P, is false. Therefore, Q must be true. But what is Q? Q is again the conclusion of this logical statement. Therefore, this is our last step to that. And the conclusion that is Q is true whenever all the premises that are negation of Q are implies P and are true at the same time. Therefore, this is a condition for this statement to be valid. Therefore, it is a valid statement. The third statement or simple example is we have P implies Q or R, the first premise, negation of R, second one, P, the third, and the conclusion is again Q. Therefore, again, formally, the proof of this statement or simple argument could be the first one is it has started from the last premise that simply P is true just because it is a premise. Second one is if we take the this one or simply the other premise of this argument, negation of R is true. So that if the negation of R is true, R would be false. R is false. And then just R is false because negation of R is true. Therefore, by definition, negation, that is R is false. Next one will be the rest, or simply the remaining premise that P implies Q or R is true because it is a premise. But here Q is true. That is, P is true, or P implies this statement to be true, Q or R must be true. For Q or R to be that of true, because R here is false, Q must be true at the same time. Unless Q is true, if Q is false, for example, false or false is false, but this one that simply P is true, since it is a premise here, therefore true implies false can never be true, so that for this logical implication to be true, if the hypothesis or simply this one that simply P is true, Q or R must be true, but from here R is false, so that the only option for this one would be the truth value of Q must be true. So that Q, that is why Q is true, that is from the 3, that is step 3 here, and a definition of implication in disjunction. But what is Q? Q is the conclusion of this argument. Therefore, this is the proof that the conclusion of this argument is true whenever all the premises are true at the same time, so that this will be a sufficient condition for this argument to be valid. Therefore, it is valid. Okay, the last example for this one, or simply formal proof of arguments, will be we have this argument containing existential and universal quantifiers with open proportion p of x and p of x. The first one is there exists at least some x, or simply for some x. P of x implies q of x in the first premise. Second one is for every x p of x. And the conclusion is for every x, q of x implies q of x. So the formal proof of this statement would be like the previous ones. The first one is that it has started from the truth value of the second premise of this one, that is, for every x p of x is true, since it is a premise. And the second one is that the second premise, that's simply this one, there exists, or simply for some x, p of x implies q of x must also be true, since it is one of the premises of this argument. Next, for every x, q of x is true. That is, for every x, q of x is true here, because from 1 to end definition of that of implication, from 1 here, for every q of x is true. From second again, for some x, q of x implies q of x is true, because for every x, p of x here is true. Therefore, for this logical implication to be that of true, that is, if for every x, p of x is true here, for every x, q of x must also be true here. That is why for every x, q of x is true. From these two previously proven or simply taken statements. Therefore, if for every x, p of x is true here, and for every x, q of x is true here in the third step here, so that for every x, p of x implies q of x will become true, which is the conclusion of this statement. That means, respond that simply for every x, q of x implies q of x is true, and so that the reason for this one is that third step that's for every p of x here is true, and using that sort of definition of that application or then, so that this is the conclusion of this argument, which is shown to be that of true. Therefore, this is valid argument. Okay, that is all what I have for today. Thanks for watching. Please don't forget to subscribe, like, comment, and share this video with your friends. Thank you.